Hi everyone and welcome to the A Plus Teachers Lounge. Today's video is all about teaching students how to solve math word problems. Have a look at this. If Mary has 3 paper clips and Jane has 9 cherries, how many more puppies are brown than cats? Unicorns? Because mermaids don't wear socks? Can you associate with this? I certainly can. Word problems really do put the EBGBs in people, especially students. They often find it too difficult. Many are so scared that they won't even try. And it's really about teaching students strategies to help them approach the word problems, not just about the answers. So today's video, I've got some tips for you and a set of strategies to teach your students. So the strategies we're going to talk about today were created by Dr.Anne Newmans, an Australian educator and researcher, who in 1977 did some research into why students found it really difficult, in fact terrifying, to actually approach solving word problems and what was involved, more than just the answer. What actually do our students need to do to get to that answer? Now, some people think that they have an ability with maths if they can quickly recall an answer or get to the answer really quickly. Actually, what that means is they actually know some number facts and they have seen it really quickly and they've applied it. But when word problems get really tricky and students can't answer it, it's because they're just searching for an answer rather than following the 5 steps. And if you teach these 5 steps, you can see that, yes, the answer is one of them, but it's a bit more than that. And these 5 steps helped children get to the answer eventually. So let's have a look at them. Anne Newman found that there were 5 specific hurdles that you had to overcome during problem solving. So the first one is reading the problem. Second is actually comprehending the problem. Third step was something she called transformation. Fourth step was processing, and the 5th is encoding. So I'm going to take you through these 5 steps. So the first one everybody totally understands is reading the question. So even good readers often find it difficult to read and decode a mathematical text. And we've found this recently when we've been working with our students on problem solving. And they find it really difficult to contextualize maths and reading in a maths context. So what I mean by this is one of the problems that we were looking at recently had the word I in it, or that's what the students thought. It said something like one book is $6, one bookmark is $5. But the students didn't read it as one book. They read it as I book. So that totally threw them and they just didn't understand and they shut down straight away. So when you're asking students to read a problem, it's important that they actually read it themselves and that you don't read it to them, that you don't put the phrasing and the full stops and the punctuation in there for them. They need to do this so that you can understand where the problem lies from the very first step. The second hurdle that students need to overcome once they've read the problem is actually understanding the meaning of the words and the graphics. And the graphics was something that came up pretty strongly in this year's NAP plan, where there were a lot of graphics supporting the problem. And if the children can't decode those pictures, just like if they were reading a story, then it's really putting them at a disadvantage. So they may confuse everyday meanings of words and substitute this in the mathematical context. So again, in the classroom, we see this when we're looking at a word problem and we ask the children to look at a table and find the information in the table. Now, before we went any further with that, we asked the children what the word table was relating to or referring to. Even though there was a picture of a table in the question, all the children sat around the table pointed to the table that they were sat at. So it's really important. It does happen. You don't think that it's going to, even though these children that we were working with had been taught about tables recently, they just couldn't use their decoding strategies and apply it in a maths word problem context. So it's important that they need to know what's relevant and what's irrelevant, and that it's a lot more, comprehension is a lot more than just highlighting the keywords. If you if you're able to highlight what's important, it actually doesn't mean that you know why it's important or what you need to actually do with that information. So you'll often see children highlighting the whole text. That's me, because when I read a word problem, everything's important to me. So this highlighting is not going to help me. Sometimes you see a student highlighting the right keywords, but then they get stumped and they just do not know what to do next. So, they just don't know why it's important. So comprehension strategies are a bit more than highlighting. The third step or hurdle to being able to solve word problems is something called transformation. So transformation is how students are able to transform the words of a problem into an appropriate mathematical strategy that will help them solve the problem. And this is where you need a full range of Polyer's strategies, things like draw a picture, guess and check, act it out, and use materials. All those things that you may have taught students to do. This is where they come in. That's step 3. So a lot's happened before we even get to this step. Step 4 is about processing skills. Teachers are absolutely excellent at teaching math skills. So they such as multiplication, addition, division and subtraction. Students pick this up pretty quickly, and they're able to follow the processes taught by these skills. However, the children, the problem is that they do not know which operation is required to solve a problem or when to apply it. And the last step to a successful problem solving is something called encoding. And encoding is being able to arrive at the solution and test that the answer works. And this one it's critical. This is where you'll find students who say the answer's 5 meters when it was actually asking how many days something took. So encoding is the last thing. So Newman's error analysis involves these 5 things. It's a bit, and I use this piece of paper when I'm working with students to assess where they're at and then I can identify what I need to help them with. So it goes a bit like this. When there's a word problem comes up, we start by following the script, just like you would with Fountas and Pennell in your reading strategies and helping to fix reading. We follow this and we say this to them: read the question to yourself and let me know if you want any help with any words. And 9 out of 10 times, until you've got the students used to this, they will say they've read it and there's no problems with the words. So of course we go straight to the word problem and I start asking them. So now they're accountable. They know that I'm going to ask them, what does the word table mean? What does this word total mean? So they already know, and then I write down some little notes here that help me when I'm teaching word problems of the stumbling blocks that come up. And the first one that we found was the word I. Kids said the word I instead of the number 1. And then when we've got to the bottom of that and had a bit of a math talk around reading the question, we then follow up by saying, can you tell me what the question is asking you to find out? Now, this is a really complex part of the problem solving process, because children see all this information and they often see the numbers to get in, 2 numbers in the problem, and they're just going to add them because they know how to add, they like adding, and they think everything's about adding. So this part here also helps children realize that we're not finding out how long something took, we're finding out how many or something. So we've been asking the children to point to the part of the problem that tells us what it's asking us to find out. So this is like things like pointing to the question mark. In simple single step problems, this is where we point to the question mark and say, what is it asking us to find out? And then the children are like, oh, right. And they're really starting to understand what they have to do, which is not always adding. The third part is transformation. And this is where we have those discussions about what could you do to get the answer. Now, this is where they'll say, we're going to add them together, or we're going to find out how many more. And we also talk about things like, can we draw a picture to find this? Can we use a number line? Can we do a guess and check or work backwards using all those strategies? And I often have a list of these strategies at the side of us, and we can select which one's the best one to give a go. Then the processing skills. So we use the mini whiteboards and the whiteboard markers, and we'll sit together and we say to the children, try doing it as you are doing it. Tell me what you're thinking. And this is where you can see if they actually are using the correct operation. If they're adding and it should be subtraction, well, you can totally get onto it because they're telling you, I'm going to take these things away. And then finally, the answer. We ask them to write down your answer. And then we go back and check, see if it works. So there you have it. 5 steps to help students solve word problems. Tomorrow, we're going to be looking at a kit that I've created with some 5 actual strategies involved. So we've got the solve strategy, the fish strategy, and the ride strategy. And that's tomorrow. See you then. Thanks. Bye.